Well, hello geometers and seekers of general truths. In this video, we will discuss lines in a coordinate plane. This is a subject that I suspect you may have learned already, but it's worthwhile to review or introduce this gently. Right, so whenever we're talking about lines in a particular plane, we're talking about writing the equation of such a line, right? So the equation here, we're going to write it using x and y, and this is an equation that has multiple variables. It has two variables, all right? So let's just look at a couple of quick examples. So let me set this up here. So let's say that I have a scale here of 1 to 1, right? So every single tick mark on the x-axis is a value of 1, and same thing with the tick mark on the y-axis. And let's say I plot 2 points here. Plot a point right here, right? And then maybe a point right here. Okay. Now, we know from very early on in geometry that a line is defined by two particular points on that line. Okay, so what we can do is just connect these two dots here, okay, and we have a particular line, right? Now, not only do we have this line, we can also write an equation for this line. Every single line has a slope, and you can calculate that slope by picking any 2 points at all. Okay? So the slope is defined by using any 2 points at all, okay, on the line. And in this case, we'll just use those 2 points that I picked, 1, 1, and 0, negative 1. So if we want to find that slope, that's change in y, 1 minus negative 1, divided by change in x, which in this case is 1 minus 0. Okay. So this has a slope of 2. And then what we can do is write out an equation this way, that y is equal to 2x. Okay. Because we know that when we increase the x value by 1, the y value gets double that. Okay, so if we go over 1, that's the run. Okay, then we have to go up 2, right, to go from this point to the other point, and that's the ratio that we're going over. Now, the other thing about a line is that every point on that line must satisfy this equation. And you can see from here that this equation is not well satisfied. The reason being is that if I were to plug 0 into here, I'm not going to get negative 1. I'm going to get 0. So I need to adjust this. Okay? So I need to subtract 1 from here. And we'll talk about how to write the equation of a line in one of the latter videos, but this is just an example. So this is the equation that works, okay? And we can test it, right? So let's pick a point here, 0 for x. Okay, so when x is equal to 0, y is equal to 2 times 0 minus 1, which is equal to negative 1. So that makes sense for this point. Let's test another one. When x is equal to 1, y is equal to 2 times 1 minus 1. Which is equal to 1. Okay, so that's this point. Okay, and so if a point is on this line, then you should be able to plug in the x coordinate and the y coordinate, and this equation would be true. Now, if we pick some other random point like negative 1, 1, right, like this point right here, this point is not on that line, and we can test it both visually just by seeing that it's not on the line, and it's also useful, we can test it algebraically. If we were to plug negative 1 in here, we would not get positive 1. We would get negative 3. Okay, so this is the general idea behind having an equation of a line. There's two variables here, and these two variables represent the coordinate of every single point on this particular line. All right. The way that I've written it here is called slope-intercept form, which we will review a little bit later on, but I wanted to introduce this idea here.